So you're going to pick some x values, and because the number in front of x is not a fraction, it really doesn't matter which ones I pick. So I'm going to pick that standard set. When it's just integers here, I'm going to pick that standard set from -2 to +2. That gets me the 5 ordered pairs that I want. Okay. So if I'm using a table method, I'm going to use these unless there's some reason to pick different values. And we're going to see some examples of when is it a good time to change those x values and pick something different. We'll see some examples like that. So if I pick -2, I plug that in. -2 times 3 will be -6. Plus 2 is -4. And then I'm working out each one of those. -1 times 3 is -3. Plus 2 is -1. And then 0 times 3 is 0. Plus 2 is 2. 3 plus 2 is 5. 6 plus 2 is 8. So I get 5 ordered pairs. That's what I want. And then I want to draw a coordinate plane and graph that. So you use that table to kind of tell you how big your graph needs to be. The smallest y value is -4. The biggest y value is 8. So I know I got to have up to 8 on the y-axis and down to -4 on the y-axis. So I know I need at least 12 or 13 blocks tall. And then my y values, from -2 to positive, or my x values from -2 to +2. So I'm just going to go, at least 10 on the x there. Just so I get a good picture, balance it out there. So that's a good, always look at that to kind of help you. And go plot those points. So -2, -4, -1, -1, 0, 2, 1, 5, 2, 8. And today we're actually going to connect those with a line, because we're graphing that line not for a specific domain. We're graphing that line. So we're going to connect that with a line, the arrow on each end, because it continues. For x values that are less than -2, it go down this way. For x values that are bigger than +2, it keep going up to the right. So we're going to connect it with a line, put arrows on the ends of it, because we're going to do some where there may not be an arrow on both ends. So make sure if it doesn't give you a restriction, then you put arrows on both ends. Okay? Real simple ideas. Exactly what we were doing last week. We're just putting it into a linear equation. It's a line now. Here's one that's not much different. Exactly the same idea. We're going to graph this line. We're going to use the table method again for this one. But what do I need to do first? Isolate what? Y. So I'm going to subtract 5x. It'll give me -5x minus 1. When I look at that, if I don't see a fraction in front of x, I'm probably just going to use the same set of x values, -2, -1, 0, 1, and 2. If there's a fraction in front of there, we'll talk about that in a minute. What do you need to do about that? But just to make it easy on yourself. So I'm just going to use that same set of x values and get my graph based on that. So -2, -1, 0, 1, and 2. Okay. So if I plug in -2, -2 times -5, +10. +10 minus 1 is 9. And then -1 is +5 minus 1 is 4. 0 would be -1. 1 would be -6. And 2 would be -11. Right? So this one goes a pretty good ways on the y-axis, because you got from -11 is your lowest value. Your highest y value is 9, so it's pretty tall. It's like 20 blocks tall. So that's a pretty good size graph. But so you just gotta make sure you got a tall y-axis. And then the x-axis, kind of generic on that. Plot your points: -2, +9, -1, +4, 0, -1, 1, -6, 2, negative 11. Notice the dots do make a line. And then we're going to connect that with a line with arrows on both ends. If you don't have a straight edge, just fold a piece of paper. And it'll make a straight edge. Fold it up, you know, a couple of times there, and it makes a nice straight edge. Long enough, you know, I'd fold one of those pieces just like that twice. And it's thick enough to run your pencil against, and it's going to make a straight line there. So, you know, you don't have to have a ruler. Just a straight edge. We're not measuring anything. We just need something to draw a straight line with. But picking out those points and getting that's what we're after here. Okay. All right. Let's look at one that's you know, maybe we need to change those X values that we picked for just to make it easy on ourselves. Technically, yes, you could use those X values every time, just like we did last week. And that works fine. And you would end up with decimals. And from what I saw last week, that's where most of us had a little bit more trouble plotting points, is when it was like, you know, 13 over 2. We struggled with where to put that on the coordinate plane. So there are ways to make that easier on yourself when you get to pick the X values. So if you had this equation, y equals 1/2 x minus 4, and you get to pick the X values, what kind of numbers are easy to take half of? Even numbers. Even numbers are really easy to take half of, right? So when I pick my X values, I'm going to pick even X values. So -4, -2, 0, 2, and 4. Those would be good X values to pick there. If it were 1/3 right there, you would want to pick X values that were not just odd, but goes by 3. So you could pick like -6, -3, 0, 3, and 6. If it's 1/4, you'd pick things by 4s, you know, 8, 4, you know, 0, 4, and 8, you know, that sort of thing. So use that denominator of the fraction to help you pick what kind of numbers. If it's a fraction there, think, okay, I need numbers that denominator will go into. That'll keep you from having to do fractions as much. Okay, so when I take half of -4, that's what? -2 minus 4 would be -6. So we work out, and it works out to be a nice ordered pair that doesn't have fractions in it. And that makes it a lot easier to plot when we go to draw it on a coordinate plane. Then we plug in -2, that'd be -1 minus 4 is -5. And then 2, -3, and then -2. You see the pattern develop there, you know, really easy. You know, we get those points, and you know, this one, you don't need a whole lot of positive direction in the y-axis because it's all negative y values, right? So we just plot those points: -4, -6, 2, -2, -5. Oops. 0, -4, 2, -3, 4, -2. We get those points. We draw a line between them. Arrow on both ends because we're certain. So anytime that's a fraction in front there, look at the denominator. Pick your numbers according to that denominator. That denominator will go into evenly. Okay? All right. Look at some exceptional equations. Y equals 2. There's no x in the problem, sir. True, but x could technically be anything. So, but y is always what? 2. No matter what x value you pick. So if you were to think about the table for this, not that you have to do a table for this, but it doesn't matter what x value you pick. You know, Michael said pick 0. Well, if x is 0, y is 2. If I pick -3, y is still 2. If I pick -2, y is still 2. If I pick +1, y is still 2. No matter what x value I pick, this equation says y equals 2 no matter what. So when I go look at the graph of that, if I plotted those points that I picked here, -2, 2, -3, 2, 0, 2, 1, 2. If I pick, 5, 2, all of those are making this horizontal line at y equals 2. That's what, and I do not expect you to make a table for these that are y equals a number. Memorize the fact that if it's y equals a number, no x in the problem, it's horizontal at that number. So you just go to 2, put a horizontal line across the y-axis. So just a memorized fact that table, this is what happens with the table. But you don't need a table to do that. You just know, oh, it's at 2 on the y-axis, straight line all the way across. It's really, really the easiest way to do that. So if it's y equals a number, no x involved, it's going to be a horizontal line at that number on the y-axis. Okay. And on the flip side of that, if it's x equals a number with no y value or no y variable in the problem, got our coordinate plane here. The table looks like this. No matter what y value I pick, the x value is always 4. So if I pick -2, -1, 0, 1, all of, no matter what y value I pick there, the x value is always 4. So when I look at that graph, it's making what kind of line? Straight up and down, right? Vertical. So it's a vertical line at that number on the x-axis. Well, you just draw that vertical line. You don't have to do the table. That's what I'm trying to say is on example D and E, if it's y equals a number, don't make a table. Just go to the graph and draw a horizontal line at that number on the y-axis. If it's x equals a number, don't make a table because it's the same thing's going to happen every time. Just go to that number that it's x equals on the x-axis and make a vertical line. X equals a number is vertical. Y equals a number is horizontal. Got to know that. Okay, that's one of the most common, I guess, things that are forgotten when you get to systems of equations in Chapter 7. I saw this a lot in my Algebra 2 class. We did a review of systems of equations, and if I threw one of those problems on there, a lot of them forgot the vertical or horizontal line part. Just memorize that fact and always know that, and then those are the easiest ones to graph, honestly. Okay. All right. Let's do just a couple of more with a little different take on a domain from what we did last week. Last week, I gave you certain x values that you had to use. Okay. On this one, what we want to use, we want to graph y equals 4x minus 6 for the domain x is greater than or equal to 1. Okay, so this is a little different take on that. Same idea, though, that if we're going to graph that for that particular domain, it's not just certain x values, it's a certain kind of x value. That certain kind of x value are x values that are greater than or equal to 1. So what kind of numbers are greater than or equal to 1? Positive numbers, number 1. What other numbers? 2, 3, 4. Those would be good x values to pick because they fit this. Okay? So that tells you, hey, you can pick any x values you want as long as they follow this rule. That's the difference in this and what we did last week. Last week, I gave you certain x values you had to use. This week, they're giving you certain kinds of x values when they restrict that. So this is a restriction on the domain, which means our graph's going to look a little bit different. It's still going to be a line, but there's not going to be arrows on both ends, only on one end. So let's plug those in, get the y values that go with that. So 1 times 4 is 4 minus 6 is -2. 8 minus 6 is positive 2. 12 minus 6 is 6. 16 minus 6 is 10. 20 minus 6 is 14. So we get a pretty good sized graph here. I'll make sure I got plenty of room in the positive y direction. So I'll put my x-axis way down low. Okay. And then plot those points. So I'm going to go to negative, or 1, negative 2, 2, 2, 3, 6, 4, 10, 5, 14. And the domain said only for x's that are greater than or equal to 1. So that means only this direction. So I'm going to start my line right on that dot and continue it to the right, following those dots. So there's only an arrow on that side, the top side of that. No arrow down here because it stopped. Because the x values that are less than 1 don't work. We're not using those. We're only using x values that are 1 or bigger. And this x value from here on out is less than 1. We can't have that. So that's where the arrow not being on both ends kind of comes into play. You got to kind of keep that in mind. Restriction on the domain. Let's try this. Y equals negative 2x plus 5 for domain negative 2 less than x, less than or equal to x, less than or equal to 4. So a little even different idea with the domain here, but it's still restricted. What numbers can we even pick here for our x values? What's the smallest number we can pick? 3 would definitely not be the smallest one. Negative 2 would be the smallest one because it says negative 2 is less than or equal to x. The equal to says, oh, you can use negative 2. And then what would be another, what does this inequality even say? All the x values have to be where? Between negative 2 and positive 4. Doesn't matter which ones we pick between there, you'll just pick some. So if I pick negative 2, I could also pick negative 1, 0, 1, 2, 3, 4. I could pick 1/2 if I wanted to. You got, well, you don't necessarily even, yeah, you do really want to start at negative 2 and go from there. You also want to make sure you got the 4 on the other end too, because those are endpoints. They're going to be the stopping places. So doesn't matter what you pick in between there. If you wanted to pick fractions, you really could, but I don't know why you'd want to. So pick some good values. We just need 4 of them in between there. So negative 1, 0, 1, and 2 would be good ones to get that graph drawn with. So that'd be 1, 2, 2 plus 5 is, wait, hold on, that'd be 1, that'd be 9, wouldn't it? And then 8, 5, 3, 1, and then negative 3. Check my math, make sure I did those correctly. Hi, Bree, did you have a question? Did you start saying it? The first one? Yeah, I missed it. But I fixed it, I think. Didn't I? Did I fix it? Well, it's still in order. I mean, it doesn't necessarily have to go the same step every time. Just long as I had long as my, technically on your table, they don't have to be in order. I usually put them in order just so I can see that pattern develop there. But they don't necessarily even have to be in order when I make my table. Most of the time, you're going to see me put them in order just because I really don't like them not being in order because it's weird. It looks weird. And it also doesn't show you that pattern that you can see with that. So you got to be careful of that. So is that right? That'd be 4 plus 5 is 9. 3 or 2, that's a 7 right there. That's wrong. Now then, the pattern's there. Let's say that doesn't look right. Then go plot your points. And now this one you've got to be careful on because you don't have arrows on either end. It has endpoints because of the restriction on the domain. -2 up to 4, and then you stop. You don't go any further in either direction. Okay? So -2, 9. -1, 7. 0, 5. 1, 3. 2, 1. And 4, -3. And even though I skipped that number, normally there'd be, if you want to put the 3 in there and do more than 5 points, you're more than welcome to. You don't have to skip it. I just skipped it because it's going to get me to the end point anyway. So it still falls in line, even though I skipped a number in the table. And again, connecting just dot to dot on that, no arrows on either end because of the restriction on the domain. And when they restrict that X value, then that's when things change. Won't do that on every problem, but they do that to some. So I wanted to, definitely go over that. All right. All right. So we've done table stuff. So exactly what we did last week. So let's dip into the X and Y intercept stuff, which actually I think is an easier way to graph sometimes. Not always the best way to graph. Yeah. But definitely an easier one sometimes because then you only have to find 2 ordered pairs instead of 5. So if you're using X and Y intercepts, it can shorten up your work. But it isn't a foolproof way of doing it. So we're going to find the X and Y intercepts and graph. Okay, so here's our equation. 5x minus 3y equals 15. Okay. The good thing about X and Y intercepts is you don't have to get y by itself on the equation first. You can do it without doing that. You can just work it out. If you're going to find a Y-intercept, plug 0 in for X. That's what you got to do to find a Y-intercept. So I would take that equation and put 0 in the place of X so that Y is the only variable left. Okay? So if you're finding Y-intercepts, Y should be your variable that's left. If you're finding X-intercepts, X should be your variable that's left. Okay? So the good thing about X and Y-intercepts, when I multiply 5 times 0, what happens to this? Cancels out, goes away. And I have this equation, -3y equals 15. We did those the very first week of class, August the 3rd. All you got to do divide it by -3. 15 divided by -3 is -5. So the Y-intercept is going to be at the point 0, -5. And then you would go find the X-intercept. Plug 0 in for Y. So we have 5x minus 3 times 0 equals 15. Same thing happens here. This part, 3 times 0 goes away, and it's just 5x equals 15. Divide by 5, be 3. So the X-intercept is at the point 3, 0. The X value goes first in your ordered pairs. So 3, 0 is your X-intercept. 0, -5 is your Y-intercept. If I go graph that, all I got to do is plot those 2 points on the X and Y axis. So if I plot 3, 0, that's right there. 0, -5. And I connect those 2. I've graphed my line with using the X and Y intercepts. Now that works wonderfully until that X or Y intercept is the origin. and then it doesn't work. Because then you only have, if the X and Y intercept is the origin, you only have 1 point. You can't connect it to itself. You don't know what direction it goes in. So if the origin ends up being your X or Y intercept, you need to make a table anyway. Okay, that doesn't happen very often, and usually I'm not going to ask you to do one that by X and Y intercepts that's the case with. But if you were by chance to stumble upon one like that, you still need to make a table if the origin is your X or Y intercept. Okay, let's do a couple more of those. What are we on here? Example I. Find the X and Y intercepts and graph for X plus 2Y equals 8. Doesn't matter what order you find those intercepts in, just find them. To find the X-intercept, where do you put the 0? In the Y. So that means X equals 8. What's the ordered pair for the X-intercept? 8, 0. Always X first, Y second. To find the Y-intercept, where do you put the 0? In for X. So we end up with an equation to solve here. Y is equal to 4. What's the ordered pair for the Y-intercept? 0, 4. Those 2 points are all we need to graph that equation, using the X and Y intercepts. So 8, 0. 8 didn't quite go far enough, but that's okay. And then 0, 4. Connect those 2 dots. I missed. We graph that line. X and Y intercepts. Quicker way, but there are some loopholes where you can't use that method. Table always works. X and Y intercepts, yes, it's quicker, but you can't always use that method to do that. Let's do one more that's maybe an exceptional one, doing the same thing, and then I'll give you your practice for today. Find an X and Y intercepts and graph in this one. 4X minus 2Y equals 10. All right, so to find the X-intercept, what do we do? 0 in for Y, so it's 4X minus 2 times 0 equals 10. So that ends up being 4X equals 10. And what do I do there? Divide by 4, but 4 doesn't go into 10 evenly. It'd be 5 over 2, right? So the ordered pair is 5 over 2, 0. Let's go ahead and find the Y-intercept, see what happens. What do I do to find the Y-intercept? Plug what in for X? 0, yeah. Good. And so that's negative 2Y equals 10. Yeah, divide by the negative 2, and Y is negative 5, so the ordered pair is 0, negative 5. That one's a little better. When I go to graph those, where is 5 over 2, 0? How much? 2 and what? 2.5. So 2.5 is right there. And then 0, negative 5 is in the same place it's always been. So when you go to graph that X-intercept, it's in between. If you want to convert those to decimals, that helps you. 2.5, sometimes we see that better, or mixed numbers. That's fine, so that you can graph it easier. That I'm okay with that. Okay, but 5 over 2, 0, 2.5, 0, 2.5, 0, all the same thing. They're all halfway between 2 and 3 on the x-axis. And then draw your line. Okay. Pretty easy stuff, right? Yeah. It's easy. It ain't working a lot. It's working some. All right, so this is what I want you to do practice-wise today. All right, on page 219, that's section 4.2, doing 11 through 21 odd. Keeping count, that's 5 problems. And then 27, 29, and 31. So that's 8 problems. On the 11 through 29, or 11 through 21, those odd ones, I want you to do the table with the 5 ordered pairs. Okay? On 5 through 15, odd. Keeping count, that's 5 problems. I want you to find the intercepts only. You don't even have to graph it. Just find the X and Y intercepts. On page 229, this is section 4.3. And then on 17 through 27, I want you to find the intercepts and graph it. Okay? So you only have to graph these 5 and these 5. These are just finding the intercepts. So you're finding me 2 ordered pairs that are the X and Y intercepts. On 5 through 15 odd, on 229, just find the intercepts. You don't have to graph those. You do have to graph 17 through 27 odd. So you're really only graphing 10 problems here today. A few more to do tomorrow, but today you'll get you started with it. It's because I knew the lesson would last a pretty good little bit today. We got about 15 minutes until lunch, or a little bit longer than that. So it's good. Go ahead and get started. If you want to make your tables on a separate piece of paper and then do the graphs on a piece of graph paper after Devin's back. Yes, ma'am. That's the table. Yeah, this is the table. Then these are the ordered. These are just the intercepts. Yeah. The first page 219, you're doing a table. 229, you're doing the intercepts. Okay.
Then after we do
27, 29, and 31. And then 229 follows instructions there. And that'll get you going for this stuff today.